All right, here's your assignment from this week. We gave it on Wednesday. The first one says a push or a pull. You're just dragging and dropping these terms over here. That first one, a push or a pull, would be a force. And then you guys can use your notes, do the rest of those. The second slide, it says you're looking at these different scenarios, identify which of Newton's laws is demonstrated. Take your best guess at this depending on the scenario. Some of them are pretty straightforward, but mainly I just want to get the conversation going as to which ones these are. But the first one, a rock will begin to move once it's pushed. Well, if that rock is going to continue to move, it's an object in motion. It's going to want to stay in motion. That would be Newton's first law. So that's why I put a number 1 in there. That number 5 down here, I put another hint. It says, as your feet push on the ground pushes back towards your feet. So you have an action force and then an opposite reaction force. Newton's third law is every action has an equal and opposite reaction force. So number 5, you'd put in a 3 here. Okay? And then the rest of them, fill those out. Slide number 3, you can Google these different examples, but it says give 3 examples of each of these Newton's laws of motion. So for Newton's first law, an object in motion stays in motion, or an object at rest stays at rest unless acted upon by an outside force. Make sure you are finding some different examples for that, maybe like pulling a tablecloth out of or from underneath some dishware or chinaware. Or from the video we watched on those car crashes when that dummy was sitting on the back of the truck and the truck took off, the dummy just fell off the back because it was an object at rest. It wants to stay at rest. So those would be Newton's first law. Newton's second law gives us the force equation. Force equals mass times acceleration. So have certain scenarios that deal with what happens if you increase mass, or what happens to your acceleration if you have a greater force on a smaller mass, something like that. But like I said before, you guys can look up these on Google. They have lots of good examples. And then Newton's third law could be bouncing a ball, pushing off on the wall of a swimming pool. You're pushing one direction, but your body's propelled in the opposite direction. So that is Newton's third law. Slide number 4, look at each image and identify the forces, or if the forces are balanced or unbalanced. If they're unbalanced, that means objects are likely in motion or something's moving. If the forces are balanced, that means there's no motion occurring. So number 1, if they're both pushing on the door here and nothing's moving, those forces are balanced. Number 2, balanced. They're not moving. Number 3, looks like she's pushing the door open. That'd be unbalanced. Number 4, you're throwing a ball. Unbalanced. There's movement there. 5, the apple's just sitting there. That's balanced. 6, those arrows indicate that if you have 2 north sides of a magnet, likes repel. So opposites of a magnet attract. The likes in this scenario for number 6 would repel. So you'd have movement. They'd be unbalanced. 7, unbalanced. And 8 shows the apple actually in motion, so that'd be unbalanced. This one, you're calculating the net force of the boxes. So number 1, you have 187 newtons going to the right, 138 newtons going to the left. So figure out which way you have more force. We have more force pushing to the right. Okay, and then to figure out how much force that would be, take a calculator, go 187 minus 138, and you would get 49. So your answer would be 49 newtons. And then you could say to the right, you could have an arrow going to the right, or say to the right. But 49 newtons to the right there. Number 2, both of your arrows are indicating that the force is going to the left. So when you do this one, you're just adding those 2 numbers, 43 plus 64, and that would be your net force. Number 3, you've got 2 forces going to the left, 1 to the right. Figure out what your net force would be after adding up all those. And then number 4, looks like both things are going to the right. Number 5 says, how do you calculate the net force when the forces are in opposite directions? Well, that's like what happened with number 1. You would just figure out the difference between those. So you would take 187, which would be your bigger force, and subtract it from your smaller force there. Number 6, how do you calculate the net force when the forces are in the same direction? Then you just add them up. That's like number 2. So add them up. Number 7, how can you tell if the forces are balanced or unbalanced? Well, if you have any net force at all when you're doing your calculations, they're going to be unbalanced. If the net force came out to be 0, then they would be balanced. And the last slide, forces in tug of war. Number 1 says Layla and Karina are playing tug of war, but neither of them are moving from their position. Explain why this is happening. Well, you could say that their forces are balanced. They must be pulling with the same amount of force, so nothing is happening. There's no net force causing an acceleration, so nothing is going on. Their forces are the same. And then number 2, or technically the second part of number 1, create your own net force problem that could explain this. Make sure you answer it. So you could say Layla pulls to the right with 50 newtons of force while Karina pulls to the left with 50 newtons of force. Calculate the net force. Something along those lines where you're setting up those forces to be the same. Number 2, Stephanie joined Karina's tug of war team. Now 2 girls caused Layla to move forward as they move backward. Explain why this is happening. Well, then you would say now the force moving to the right with those 2 girls is now stronger than the force pulling to the left. Create your own net force problem that could explain this. Well, then you could say you have 2 girls pulling to the right with 100 newtons of force, and you have 1 girl pulling to the left with 50 newtons of force. What would be your net force? And you'd come up with 50 newtons to the right. And that's why we know that those 2 would be winning the tug of war. And that is the assignment. Let me know if you have any questions. Otherwise, good luck.